Hey everyone, so I've been learning about some more advanced redstone concepts such as encoding, RAM, serial data transmission, etc. And encoding and serial data are two things that are fairly new to me, so I want to combine them into something that I can hopefully use to teach myself a bit more and get more used to the concepts. And to do that, I'm going to make a messaging system where you can input a character of the alphabet and it will send it, and then at the other end you will be able to receive it with redstone lamps probably, and I made a diagram to explain it in more detail, and I'll run through that in a moment. But first, please remember to like the video if you do find it helpful, interesting, or entertaining. Leave a comment if you have any suggestions, and if you would like to see more similar content, please remember to subscribe. Anyway, let's get started with the plan. Here's the diagram. We've got input, binary conversion, which is the encoding and decoding, and then serial transmission. So firstly, you'll take input, and this is going to be just redstone lamps with levers, and there's going to be 32 of them. The reason is that 32 separate options can be transmitted over 6 bits of binary data, so that's what I'm going to use. So then this is going to be encoded into, like I said, 6 bits of binary data, which is then going to be converted to serial. So a transmitter is going to convert this into serial data, transmit it across a redstone wire, and this wire could be however long you need. It could be a long distance communication system, so you could go up to over like thousands of blocks if you really wanted to. However long it is, at the other end there will be a receiver which will convert the serial data back into a binary, and then the binary will be decoded into one of 32 different letters / punctuation. I think that made sense, so let's get started with input. Okay, so I was going to use redstone lamps for input, like this, just a whole bunch in a row with a space between them. Now that's going to be very wide when we have 32 of them, so I was thinking I could do it like this, have them up and down like this, but I don't think there's a way to fit a encoder and decoder in a space like this with them right next to each other. So I went with the first option, and I've got 32 alphabetical redstone lamps with the alphabet and then these symbols. So we got space, a full stop or a period, exclamation mark, question mark, the and symbol, and the $sign. Okay, so now we're going to make the encoder. Now this is a very simple and repetitive process, so I'm only going to do the first 4 and then I'll do the rest off camera. So 1, 2, 3, 4, 5. Okay, so you'll have all your inputs here and your outputs along here. Actually, we're going to need 3, 4, 5, and 6 outputs. So yeah, okay, we're gonna have 6 outputs. So I'm only gonna do it for these 4. So you need 1, 2, the 5th block from your input can be your first output line, and then also you're gonna put redstone lamps at the end. Since we're only building a decoder right now, we're just gonna have redstone lamps to represent the output. But actually, this will just lead to the next piece of the whole system. But for now, we'll just use redstone lamps to represent it. So now, what are you going to have? So redstone dust and then a block, and then you're going to go up a block. Now, this is just going to connect straight into this block. You do not put redstone dust on this block here, but you do put it on the next one. Now, because there's a redstone torch under here, this is going to be the opposite of whatever you input. So that's an inverter, also known as a NOT gate. And then you're going to run this for the whole length of your binary outputs up to the last one, and then just run redstone dust all across it. Now you're going to put a lamp at the end, just to make sure that it's got signal strength. If not, you can just put repeaters. Make sure you put repeaters in between the ones where it doesn't have redstone dust underneath, because if you put it here, eventually you're going to need redstone torches here, and that's not going to work because then the repeater will get in the way. So then just repeat this process for all your inputs. Okay, and then you're going to actually make these connect to it, because right now, if you turn them on, it won't do anything. So what we want to do is, so the first, okay, A, we want that to turn into just the number 1, which is going to be 0, 0, 0, 0, 0, 1. So we want that to just activate this one. And to do that, put a redstone torch over that line. Now currently you'll see that because there's redstone up here, this torch is disabled. But if we turn this on, it flips it around and it turns that torch on. Now the next one, we want it to be here. Okay. So this is going to be for B. B is going to activate. B is going to be 1, 0. So now if we turn off A, turn on B, we get 1, 0. So all you have to do once you set up these lines of redstone across the top is just place redstone torches on whichever ones should be activated. So we want C to be 0, 0, 0, 0, 1, 1. And now if we turn on C, that is exactly what we get. And now the last one is just going to be D, which is just going to go there. And so now we've made an encoder for the first 4 letters. Okay, so now we can just do it for the rest of all the alphabet and punctuation. Okay, so here I'm making something called a truth table, which is basically saying that if we input whatever's on the left side of this vertical line, then we're expecting this to be the output. So for A, we should get 0, 0, 0, 0, 0, 1. B should be 0, 0, 0, 0, 1, 0, etc. all the way down to here. And in doing this, I realized something. 6 bits does not give you 32 outputs. 6 bits gives you 63, and 5 will give you 31. Now, I think we don't really need a $sign, so I think we're just going to take that out and have 31. And then we can take the 0 off the start of every single one of these. So that is what I'm going to do. And that means that also I can take off one of the outputs in the Minecraft world. I've got all 31 of the letters / punctuation, and they turn into various 5-digit binary outputs. So we can turn on any one of them and see a unique code at the end here. So that means the encoder is done, and now it's time to make the serial transmitter. It's time for the serial transmitter, but firstly, what exactly is serial? Well, all it means is that the data, instead of being transmitted over multiple lines of binary, is transmitted over one line, and the way it does it is with timing. So, for example, if you have this message, so it's like 01010101, the line would just go on and off very quickly, and then this end knows it knows how the timing works, so it can interpret it as 8 separate messages instead of just one flashing piece of redstone. So if we clear the data over here, and then send it again, you'll see they go down one at a time and then they separate. Because it's happening so fast, you can't actually see them alternating, but it sends them one at a time, flashing. Basically it's flashing on and off, but you could do any piece of data. You could have it be this message, and then when I send it, oh, also I have this button also attached to the clear button over there, so that I don't have to run back and forth, and then it will send it, and you'll end up with this message, which is the same message as here. So all serial really means is that it sends data by alternating one wire, well, not back and forth, but it just reads through the message in order. Now this one is set to do it at 1 bit every 2 ticks. So you can see these repeaters are on 2 ticks. So every 2 ticks it sends one piece or 1 bit of data. So it'll be on, off, on, off, on, off. And it's just going to send that down, and then this side just knows that it needs to receive the message one at a time. But how does it work? Oh, I've been online for 6 hours. But how does it work? Okay, well, this button generates a 2-tick pulse. This is just a pulse generator. And then it will invert all these redstone torches. So as you can see, when I turn this on, those redstone torches will turn off for 2 ticks, which means that because these comparators are in subtract mode, so having this going into the side means that they don't send out the information. When I remove that, you can see it actually sends out these bits of data. So by inverting these torches, it allows the data to all go through. Now these repeaters are all 2-tick repeaters, so basically every 2 ticks the data is going to travel down 1 step at a time. So this bit will move here, and the piece that was here will end up over here, and they'll move down 1 at a time, and then each one will reach this point eventually, and this point is just what gets sent. It could be thousands of blocks, or maybe not thousands, but it could be a long distance over to the receiver. So, and then you just have one piece of redstone wire, and it's transmitting all this data. So that's, I think I've covered it all. Yeah, it's not that complicated. It's a pretty simple circuit for the encoder. So let's go build one over here. Now I've already done it. So you can see we've got the 5 binary outputs from the whatever letter you select. So currently we've selected Y, which has the code 11001. So then we have the pulse generator, just simply creating a 2-tick pulse. I've built it the other way around, so the torches are on this side. So that will deactivate these, which will unlock the comparators, and the data will go through, and then it will travel down 1 by 1 to this point. Now, I'm just going to get a redstone lamp, which is up here, I believe, yeah. And now, I'm just going to make a stack of torches so that we can view the data easier, because if I stand over here I can't see the redstone, but I can see that lamp. So now we're expecting it to go on, off, on. So when I press this button, you'll see on, off, on. You'll see the first on was longer than the second one, and that's because it's doing 2 in a row. So if you look again, it's like the second flash is much shorter because it's only 1. If there was another piece of data here, that would be equal in length. So yeah, the encoder is working. So now we just have to build a decoder. Okay, so now let's talk about the decoder. So again, it's fairly simple. It's just taking in this, basically just a flashing redstone wire. So every 2 ticks is a new piece of information. So it comes in, and then there's all these 2-tick repeaters. So the first bit will end up here, right? And then when the first bit is here, the second bit will be here. And then it continues down here. And when the first bit is here, when the first bit reaches the end, that must mean that all the bits are in the correct place, right? So how do we store the information permanently? Like you see, when you send something, it doesn't just flash there for a second. It stays there until you clear it. How do we make it do that? Well, if you don't know, actually let me trigger it so I can show you. If you don't know, there's something you can do with the repeaters, which is called locking them, which is, as you can see, there's like this bar of like bedrock looking stuff. So if you send a repeater into the side of a repeater, it will lock it, which means that now, even if you change, if I grab a redstone torch from here, even if I change the input here, it's not going to change what goes through the repeater because it's locked. Yeah, so it's locked here, and then so that basically saves it. So technically, the data coming in here is 0 now. So if we unlocked it, all the zeros would just feed through and everything would get deleted. But we've locked the repeaters at the exact right moment that the data stays in place. So to lock them, we just send a redstone torch into one big line to lock them. But here's the question. How do we know when it's the right moment to save the data? Well, this right here is a timer. What it does is it goes, okay, so we need to wait exactly this amount of time because it knows there's 8 bits of data. Well, I know that, so I put the right amount of repeaters. So we've got 1, 2, 3, 4. These 4, ignore this one for now. I'll explain why you're ignoring it in a second. But these 4 are the ones for the data. Each one is the time it takes for 2 bits of data to come through. So this is a default repeater. Then you click it twice, and it goes to there, and that is worth 2 bits of data. Then this one is because, okay, say you have this. Now this bit is this is empty, so it looks like this is the first bit. So then it would get to this point, and then it would go here. It wouldn't stop here. It would go here because it would continue up to the first bit. But say if the first bit is a 0, like it is now, we want it to still register that. So we add an extra bit to the front, which is always on. We call this the signal bit. And this is used to indicate that, okay, there's an incoming message. It's exactly the same, it's just a 1, but it's always a 1. So that doesn't have a lamp. If we added another lamp over here, in fact we can, I can't be bothered, but we could add another lamp up here, and that would always be a 1 every single time, because the signal bit is always there. But that's not important information, it's not relevant to the actual message. All it's used for is to make sure we stop it at the right time. So it comes in, this chain is to actually take in the data, and it splits off here to, oh also, this line, just ignore this. All this is doing is so that we can clear it. As I said before, that's also linked to the clear button. Ignore this. But this one, it splits off. It just has a repeater here, and then a 2-tick repeater here. These two add up to another one of these, because basically the signal bit is just another bit. So these two, it's a 1 and a 2, which adds up to a 3 over here. So imagine that there's just another repeater. So yeah, it just takes it in. The signal bit causes it to start the timer, and then at the end of the timer it will go, okay, we have to assume that there's a full message here, lock everything up, and yeah. So the signal bit is how it checks the right time to lock it. So now let's go build a decoder over on our messaging system. I've added this redstone line, so you can imagine that this is a long distance, because like there's no point realistically having it just go to here. But there's also, this is a demonstration, so I'm not going to build it 100 blocks that way. I'm just going to build it right here. But imagine this was longer. Anyway, let's build a decoder. I just realized I've been using the wrong terminology this whole time. I don't know if that is technically a standard, but the way. So you have an encoder and a decoder for binary, and then for serial you would have a transmitter and a receiver. I don't know if that's actually the standard, but I think I might have been a little confusing before. Hopefully you understood, but I'll try and stick to what I'm saying in the future. But encoder, decoder, transmitter, receiver. So as you just saw, I finished building the serial receiver. I then started working on the next part and realized that my recording stopped working, so I have to re-record this bit. So just focus on the lamps, ignore all this redstone. But let me demonstrate what we've got so far. So if I, yep, okay, so we've got a lamp on. Let's just turn it off, and let's send an, it doesn't really matter, we'll just send an I, for example. And then we'll come over here, see we get the binary representation, which is 0, 1, 0, 0, 1. Then, actually, we need to clear this line over here, actually. That's empty now. And so now we can send the data over, and we get, we get 0, 1, 0, 0, 1. Now, so that means so far we've got encoding, transmitting via serial, and all that's working. So now we just need to make a decoder, and that's what I'm starting on here. So I've just got it coming all around the corner so that they line up, because if I built the decoder this way we wouldn't have enough space, I don't think. So just to be safe, I'm building it this way. And I've already made these are going to be the outputs. So to figure out how much space you need, I'll just teach you what you do first. Get all your binary inputs and just do this. Actually, I'm going to disconnect them, and then we'll build it, and then I'll reconnect them. Get all your binary inputs and put one piece of redstone dust, and then put a block in front. And now this is the repeating structure you're going to use. It's just going to go up and down over all the redstone lines like this. So it's like it's kind of going up. It's like a, I don't know, kind of like a snake going back and forth. But you need to have one extra like curve, I don't know what to call it, but you need to have one extra upward block before the start of it, so that you can put in, well, I'll show you in a moment. I'll show you why in a moment. But you're just going to build all of these, and then you're going to place, so you're going to have redstone dust up, just going up the stairs up to the top one, and then you only on the top ones you put another spot of dust, and then in between these, on the ones that are touching the ground, you put a repeater. Just leave it as a default repeater. Do not touch it to change the timing. Just leave it like this. So basically, all the ones that have redstone underneath on the floor will have redstone here on the block above. Now, because this uses repeaters, you can make it as long as you need, and you won't have to worry about like signal strength, because there's a repeater every second block. It's never going to run out. Anyway, repeat this process for all of these. Okay, so then you need to add at the end of each output line a block, a redstone torch, and a lamp. So this one's called A. So now we actually make this linked to whatever our code is for the letter A. So letter A should be, actually, why don't we transmit a letter A, just so we know what it should look like. So we'll clear it, and we'll come over here, select the letter A, and then come back over it. Oh wait, no, we need to transmit it via serial. Yeah, transmit, and we get this. So this is what A should be. A should be 0, 0, 0, 0, and then this side should be a 1. So, well, how do we do that? Well, this line here is A. So you're going to go down this line, and, okay, this bit should be a 0, 0, 0, 0, but this one, we want this to be a 1. So how do we indicate that? You put a redstone torch here, but you also have to take out this repeater. So any of them that have a redstone torch, you take out the repeater before it. And you know it's before it because of the way the repeater's facing. So you take out the repeater before it. I hope that makes sense, but I'll do the next couple just to demonstrate a bit better. Then you get B. Oh, also this is why you invert it, because it has a redstone torch, right? And then, so that means that was on, but now it's inverted. So now when you get this signal, this will turn off, and then all of them will be off. And then only when they're all off, this will be on, and it will turn the lamp on. So now let's do it for B. So for B, I'm not going to transmit it. I know what we're expecting. It should be 0, 0, 0, 1, 0. So to do that, we go here, and we go 0, 0, 0. This one's a 1, so we break the repeater and replace it with just some redstone dust. And then we place a torch. Then we go 0, 0, 0, 1, 0. Now let's do it for C. And then we get, this one should be 0, 0, 0, 1, 1. 0, 0, 0, 1, 1. And you get the idea. But I said I would do 4, so we're going to do D as well. D will be 0, 0, 1, 0, 0. So we just need to change this one here. And now you can see we got a decoder, but just to be sure, right, we know we've got an A here. So let's connect this back up and see what comes out. and voila, you have an A. So let's just send something else to make sure it's working. Let's send a D, and then see if we get a D on the other side. So we send it through, serial gets converted into a D. Look at that. Okay, so now all we need to do is make all of this for all the rest of the letters. So technically, we have a fully functioning prototype now. It only works for the first 4 letters. So I'm just going to go off camera and build the rest of the decoders. So I finished making the decoder, and oh, this took a long time. However, I realized that I was wrong about one of the things I said. I said that you don't have to worry about signal strength because there's a repeater every second block. But the thing is, sometimes there's not, because like there's a whole thing here, like this whole section, all of them have a 1 on this bit. So they all need these torches, which means there's no repeaters, so I added 1 in. To add in the repeater, make sure, well actually I'll just show you how I did it. Just come back here, disconnect them all, and just give them all like power, and then see where the signal gets up to. So here, you can see they're all deactivated except for this one. So I guess I could just put the repeater here, but I don't know, I didn't like the look of that, so I wanted to put it in the middle. So I think I put it here. The important part is you can't put a repeater along with a redstone torch, because then it won't cancel out that redstone torch when it's supposed to, so you put it here. Then there's, just check at the end of each like long stretch, yeah, see this one, there we go, and then this, oh wait, I forgot to put, because I did this side all as one, I forgot to put all the redstone torches along here, but nonetheless, we'll see how far it gets up to. Okay, so yeah, it can only go up to there, so we'll put a repeater here, and then keep placing in the torches, and I think that hopefully will be enough to get us to the end. Oh, not quite. So we'll place another one here, and then there we go. Why is that? Did I send in? Is that what I sent in? Oh yeah, because I gave them all power. Right. Okay, I wasn't paying attention. Yes, if you give them all power, it will give you the last character. Okay, so now oh no. Let's actually connect it up and see what we get. Why did I go to the grass block? Okay, whatever. Here we go. Now we get a G, I believe. Yep. So now that that's finished, let's just clear it. And test it by sending in something else. Let's see. Let's send in a exclamation mark. Okay, we got the code there. You can see the binary code. Send it in over serial data. Get the binary over here, and then decode that into a message, which should be down this end. And as you can see, we've got the exclamation mark. Okay, so according to the original plan I made, this is it. We've got input, encoder, and serial transmitter, and then you could imagine a long distance here, and then receiver, decoder, and output along here. However, let's be honest, say you're talking to someone in your Minecraft world via something like this, you don't want to have to run, that's like 100 blocks at least. I can't visualize it. 13 to, okay, no it's not, it's 60 blocks, but you don't have to run, you don't want to run up and down 60 blocks to type out your message, really you're sending characters one at a time, but still, you don't want to run up and down 60 blocks. That's going to take a lot of hunger if you're in survival mode. So I want some different kind of input method. And also the same applies to output. This is also 60 blocks, right? You don't want that. So I'm gonna make for input I'm not sure yet, but I'll work on output first. I'm gonna make a 7-segment display. Now here's the thing. You have 5 digits of binary coming in, and then you decode it into individual characters. Now to get it into a 7-segment display, you need to encode it again, but you can't go straight from 5 to 7 because it's not the same. You have to decode it and then encode it into the corresponding, like, which lines are on for the 7-segment display. So that's what I'm going to work on now. So all it's going to be is just another encoder for a 7-segment display. So yeah, let's do that. Okay, so the 7-segment display is done now. It's literally just taking the output from the decoder and then re-encoding it in 7-bit to this display. There's a whole ton of repeaters, not just here, but also underneath, because it's such a long signal. And the repeaters from, well, there's also a lot of repeaters in here. So because of all that, there's quite a lot of delay. So it takes a while for it to update. But I can demonstrate it. The other feature I added was this button now also leads over to the clear button, so that you can add new data without having to run and clear it and then come back. And also there's a delay here, so that it will clear it and then make sure it has enough time between clearing it and sending new data, so that it doesn't interrupt and accidentally send the wrong data because the clear happens at the same time. So let's demonstrate this by sending in a letter. I think they're all off right now, so let's just send in the letter H, for example. And then we can press this button, it will clear it. You'll look at those lamps over there. It will clear it. You can see it clear them, and then send the data. And you get the H, which matches this. And then that's going to go through the decoder. And now it's done in the decoder, you can see it here. And it's coming through here. And then we have a H. So yeah, I've got a working display now. If you wanted to just make a display, you wouldn't need any of this sending data stuff. You just put that 7-bit encoder instead of this 5-bit one, and then just put the display at the end here. But obviously, the point of this is the communication part, the serialized data across here, and then the encoding and decoding. This is just an afterthought. So yeah, the other thing I wanted to mention was input. As I said, this is like 60 blocks long and you don't really want to run up and down that. So I was thinking something along the lines of this as a different input method, and then like each line would come out and snake over to the right spot. I can't really be bothered setting this up fully, but this is the kind of thing I would use if I was going to actually build this like in a survival world to actually communicate with people. So yeah, we've got input, it's not perfect, but it is input, encoding, transmitting, receiving, decoding, re-encoding into a display. So I also want to talk about when you would actually use something like this. So the main idea, right, is long distance communication. But say you just use encoding, right? Then you still have to send 5 redstone wires over a long distance. Like if you wanted to send it over like 200 blocks, right? You have to, that's like 1,000 redstone dust, 200 times 5, versus just 400 here. But the thing is, serial data can handle any amount of bits. You could have a 64-bit like message here, right? Like 64 bits of binary. And oh, sorry, the recording crashed a little bit. You could have 64 bits of binary, and it would still only take one serial wire to communicate the whole thing. It would just take longer. So any amount of data can be compacted down to 1. Like that's the bare minimum. You can have the other one to clear it if you want, but you don't have to. Like, so it is you could go from 64 times 200 down to just 200 redstone, and that is a significant improvement. I would say adding the clear functionality is worthwhile because otherwise you're relying on the person on the receiving end to just know when to clear it, or to like read it and clear it immediately afterwards, because otherwise, like say you send one letter and you assume that they've read it, so you send the next thing, but they haven't read it. They're going to get the first one, but the next one is just going to come and go and never get put into the system. So they're only going to get the first one. And if you send lots of letters, they're just going to miss most of them. So having the ability for the sender to clear it allows them to send the data, and they can clear it once they're ready. It's still possible for the person on this end to miss it, but if they're standing here, they're more likely to get everything rather than just leave it alone, and then half the data will just not get interpreted by the decoder. By the receiver, I mean. Anyway, I think that about does it for this project. So you can input data, send it via serial over to a display. Probably took way longer than it should have, but hey, it's the first time I've used a lot of these kind of things, and I think it came out to a pretty interesting result. So thank you guys for watching. I hope you enjoyed, found it educational, or at least found it interesting in some way. If you did, be sure to leave a like. If you would like to see more content similar to this, make sure to subscribe, and if you want to, leave a comment with any suggestions, feedback, ideas for future videos, or anything else. Thank you for watching, and I will see you in the next video. Bye!